In section 1.1, you learned about 3 different strategies for Virgin problem solving. You learned the guess and test method, the draw a picture method, and the use a variable method. So in this section, we introduce 3 new additional strategies, and those are looking for a pattern, making a list, and solving an easier problem. So in the last video, we actually saw how this can be applied, solving an easier problem. That's a very common technique that you see interchanged with or used in conjunction with a bunch of other different problem-solving strategies. This one I think comes up a lot, as well as drawing a picture, using variable. And so for this video, I want to focus on the looking for patterns and making list strategies. But this one's going to kind of come into play a little bit in this one too. So I think these all can be very nicely illustrated in this one following example. What is the ones digit of 2 to the power of 4,179? So if you were to go to your calculator and type in 2 to the power of 4,179, you would probably get some obnoxiously large number, and you would probably not even be able to read that number. Depending on the calculator that you're using, you might not even be able to figure out what the ones digit is. Just this number is just really, really huge. So you need to come up with a different strategy for figuring out what this is. So how do we actually go about doing this? All right, well, the goal is to, find a pattern somewhere that would maybe help us generalize and figure out what the ones digit should be here. So, so here's what we're doing. We're going to write down the first couple powers of 2. So 2, 4, 8, 16, 32, 64, 128, 256. I'm going to keep going here. 512, 1024, 2048. This next one, 5096. And we could keep going here if we wanted. It started to get kind of hard for me, mental math wise, so I'll kind of stop there for now. And so now we have like a decent list. And so the goal is, let's find a pattern somewhere in this list, right? So let's look at the ones digits of all these numbers. So let's go through and actually just highlight ones digit. So of course, 2, 4, 8, 6. 2, 4, 8, 6, 2, 4, 8, 6. And so hopefully you're able to recognize, oh, hey, there's a pattern here. Every 4 powers of 2, the ones digit kind of cycles between 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. And that just kind of keeps on going. So it seems like there's a pattern there. And so just looking for a pattern or seeing a pattern in like the first couple of entries of a list can very much be dangerous. You could, because I mean the pattern, like for all you know, like the pattern could break on the 17th term, right? There's no like necessary reason that like the pattern must keep going after like the 17th term. And in fact, if you go online and just like search like patterns or things that seem to be patterns but like aren't actually patterns, like there's a bunch of like really weird examples of things where it seems like there's going to be a pattern, but after like the 500th term or something like that, the pattern just totally breaks. So you have to be careful. The way that I would recommend being careful is generally, if you see a pattern, try to figure out for yourself, why would that pattern actually have to be holding true? Why does this pattern make sense? Just seeing if you can explain what's going on with the pattern and why it might be there. So we're gonna come back to that question a little bit. For now, I'm interested in actually just like solving this, answering this question, and figuring out what do we think the ones digit should be. Sort of just get a guess out there. So let's to answer that question, let's solve an easier problem, right? So what if this said 2 to the power of 16? That's a much smaller number, right? So here's the thing. Every 4 powers of 2, the pattern's going to repeat. It's going to go 2, 4, 8, 6, and then repeat from there. So what I want to do is break this up into a bunch of powers of 2. So this is 2 to the 4th times 2 to the 4th times 2 to the 4th times 2 to the 4th, right? Because if I were to multiply all these together, there's 4 powers of 2 here, plus 4, plus 4, plus 4. So 4 plus 4 plus 4 plus 4 twos is equal to 16 twos. So this is a product of 16 twos over here, right? And so, yeah, so we multiply 4 twos here, 4 more twos here, 4 here, and then 4 here. And so, let's see, I think that should tell us that the ones digit should be a 6, because we go 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. And then so right here, the 16th entry of our list, if we were to like go up all the way to 16 terms, the 16th one would be a 6. So the ones digit of 2 to the 16th is going to be a 6. Likewise, if we were to do 2 to the, let's say like 21st or something, this would be 2 to the 4th, 2 to the 4th, 2 to the 4th, 2 to the 4th, and then times one more 2 over there, like 2 to the 1st. So we have a bunch of 2's grouped in groups of 4 over here, and then we're going to have one more 2 at the end here. So we have 22's over here, and then one more 2 over here. And another way that you could write this is 2 to the 20th times 2 to the 1st, or you could write it as 2 to the 4 times 5 times 2 to the 1st. And so every 4 powers of 2, the pattern's going to repeat, and you really only care like what happens like over here, right? There's going to be one more power of 2. So we go 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6, and then 2, right? So we would say the ones digit of 2 to the 21st is going to be 2. So we're grouping our numbers in groups of as many groups of 4 as we can, and then we see how many 2's come after that, and then we use that along with our conjectured pattern to kind of come up with an answer here. All right, so we're looking for 2 to the power of 4,179. Let me bring that down here. So 4,179. I want to break this into as many groups of 4 as possible. So I'm going to divide this by 4, and I really want to do this like with remainder. So let's do that. I'm going to move this over here and then just do long division the way that I normally would. So 1, see, 10, so this 10 times 4 is 40, 7, 4 goes into 17 6 times, and then 19, so the 4 times 4 is 16, and it looks like we have a remainder of 3. So 2 to the 4,179 is 2 to the 4th, and then we do that 1,044 times, and then we're going to multiply by 3 more 2s. Right? So that's kind of what's going on here. So pattern goes 2, 4, 8, 6, 2, 4, 8, 6, 2, 4, 8, 6. We do that 1,044 times, and then we're going to do 3 more products, powers of 2. So we go 2, 4, 8, 6, blah, 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 up to 2, 4, 8. And so it seems like the ones digit of this number to the 4,179 is going to be 8. So like I said earlier, you want to be careful that your pattern is actually a pattern, and that you're not just kind of making stuff up and finding patterns where there really is none. So ideally, best case scenario is you can actually justify this pattern for yourself. Okay, so let's see if we can make sense out of this. So let's say that we're somewhere at a place where the pattern has still been holding up. So the ones digit should be 2, 4, 8, or 6 at that point. So we have some number. I'm just going to kind of write down some numbers, thinking about variables. If it were just me doing it, I would probably jump straight to using a variable here. But let's just say like I have a random number. This won't really be a power of 2, but let's say 5, 7, 1, 3, 8. Let's pretend that this is like a number in our sequence. And let's say that we multiply this number by 2. So the pattern would say that the next number, the next ones digit should be a 6. Right? So if we do that, so this part of the number is not really going to matter here. This 8 right here, when I multiply this, I'm going to get 16. So I'll bring like the 10 up there. And then what I get over here is not going to matter, right? So I multiply this thing times 2, and I'm going to get like just a bunch of stuff. And I like carry this like 1 over here. But the only thing that really matters here is that the ones digit is going from a 2 to a 6. Something to note here is that 57,138, this is really, you can think of it like this, 57,130 plus 8. If you were to multiply this by 2, then you would get, well, this right here is just like some multiple of 10. So this is like 2 times a multiple of 10 plus 16. And so you could break this 16 up as like 10 times 6. And you could like combine like this 10 over like with the multiple of 10 over here. So you'll get some different multiple of 10 over here plus 6. And so overall, your ones digit is going to be 6. And you could do this for like if the ones digit was a 2, or if the ones digit was a 4 or a 6 or whatever. So the pattern's just always going to hold here. And so with all of that in mind, that's how we would go about like fully justifying this solution to ourselves.